So, an introduction to cloud services. At the end of this lecture, you should know the main types of cloud services, the difference between an operating system, a virtualization, and a container, some of the essential services provided by Amazon AWS, and also which steps are required to launch your own server instance on the cloud, which is also something you will practice during this week's lab session in the afternoon together with Tom Vermeijeren. So first of all, what is the cloud? So the cloud, yeah, it's a very abstract term. I think we all have some idea what it is, but in this context, we mean a cloud service is any service made available to the user on demand. So that's important. It's on demand. Basically, you rent resources either with a yearly subscription or just for 1 hour, especially if you're practicing, you can just rent a server for 5 minutes or 1 hour. And you do that with these different vendors. So you have AWS, Google Cloud, Microsoft Azure. These are the major suppliers. So they have data centers scattered around the world. Each data center consists of a number of racks with a whole lot of computers in them. So I'm not sure what the current capacity, for example, is with AWS or Google Cloud, but they have millions of computers in racks around the globe. You use these services, for example, if you use Gmail or Hotmail or something like that, or Netflix, you use those services. But in this course, we go one layer beneath that, and we will use their infrastructure and make our own websites. That's something you could do for your organization, create your own servers on top of their infrastructure. And you can use that for storing data, for computation, and for serving applications through some kind of web-based interface. That's the cloud. How do you manage your own account? So you have an account in the lab sessions. We use awseducate.com. And you can manage your servers, your databases using a web interface. That's the most important part. It's very easy to do, and if we have time, I'll show you some examples. Otherwise, you will practice it together with Tom. But it's really easy to use, and I would suggest you really try this web interface, because I can explain it in the slides, but often it's much more clear if you just try the web interface, and you will see it's not that hard to set up, for instance, a server. You can also use command line tools, and you can also use HTTP requests using getter posts. So that means you can actually write a Python program that starts new servers or do things like that. So the cloud stack, so there are basically 4 types of services, and we call that the cloud stack. So the first type of service is on-premise. So actually that's not in the cloud. You can say you make your own private clouds in an organization, but what you do there is you really buy the hardware, you buy the router, you connect network cables between all your servers, maybe in a server rack. You're also responsible for making sure all your hardware has enough power, that there's some physical safety. You install the operating system, you create backups, you configure the network equipment so it's secure. So that's the first option. So obviously that's a lot of work. You can see it in the diagram. Also when there's changes, so if you need new hardware, you should buy them. If your hardware breaks down, you should replace it. A lot of things you have to do yourself. And then the next type of service is infrastructure as a service, or IaaS. And that's what we'll practice today in the lab session on Amazon EC2. So here you actually rent computers. So often it's virtual hardware. We will go into that in a couple of slides. But basically you rent computers, you rent storage, you rent infrastructure for networking, and you don't have to worry about the hardware layer. You still have to install your operating system, your application. You still have to select rent disk and check where you're going to how you're going to store your data and stuff like that. But you don't have to worry about the hardware. And then one layer, the other extreme actually is software as a service. So in the diagram, that's the last column. So there, it's a method for delivering software over the internet. So actually, that's something you're used to. So your Gmail, your Dropbox, Facebook, Office 356, those are all examples of software where actually everything is provided by the cloud vendor. So they install the application, they decide where they store the data, you just use the application. So that's the highest abstraction of a service, software as a service. And often as an organization, you want to make your own software available as a service. And then you have something in between infrastructure as a service and software as a service, and we call that platform as a service. And there you don't install the operating system or also the middleware, so you don't install the databases, but you do control your application and you do control your data. So we will see some examples of that. Okay, so what are the advantages of cloud computing? Well, first, from a procurement perspective, there's no need for large upfront investments in infrastructure. So that means you decide, you rent the amount of IT resources you need within minutes. Sometimes it can take a couple of minutes, but minutes is usually the time you have to wait. So it's basically on demand, you pay as you go. So you can rent, for example, 100 servers for 1 hour, and it will cost as much as renting a single server for 100 hours. So you're very flexible in that way. Maintenance, it could be cheaper than maintaining your own data center. So obviously, if you use a lot of, if you rent a lot of services 24/7 every month, it will be a high bill. But if you maintain your own data centers, there are a lot of more additional costs. You really have to account in the time it takes to order your hardware, the power supply, the office where you're going to store your hardware. So it could be that it's cheaper to use the cloud than your own data center. And now it depends. You should do that's an entire study. That's always true, but often it can be cheaper. Also for capacity planning. So normally, if you have a server, you have to make sure that its capacity is enough to handle your current loads. For example, if you expect 2,000 end users using your server, you might need 10 servers each with 16 gigabytes of RAM. But maybe at night they're only used for like 1%. And so that's also an advantage with the cloud, that you can scale up or down within minutes. So if there's suddenly a peak of users and you need a lot more memory during that period, you can just scale up for a specific period, and then it will cost less than always having to require the computing resources to manage all the computation and data handling at peaks when there are a lot of users using your system or something like that. And then finally, also redundancy and availability. So you can launch your servers across many regions. So even if there's a physical earthquake or something, or some large natural catastrophe, you can still have your data safe in another area, even another physical location. Security, you inherit the security of your cloud provider, and it's easy to separate your storage from your computing resources. So usually, if you store, say, data in some location, you also want to process data in that location, because copying data over the internet can take some time. But in the cloud, it's all conveniently to manage that. So here's for example how AWS is organized. So they have several regions across the globe, especially with European regulation. Often it's required that your data is stored within Europe. So they have a big region in Ireland. So within each region, it's possible that you have several physical data centers. So these data centers are quite large. They're a couple of square kilometers. But even within one region, it could be that you have separate physical data centers. And there's in our AWS, they're suffixed with a number. And then you can expect within a data center to have a super fast gigabits type of network. So within one data center, the communication will be quite fast. Okay, so that's a little general introduction in the cloud. Let's talk about virtualization. So virtualization, it's used by default by these cloud vendors. You can also do it, install it locally. But in essence, virtualization is a kind of simulation of your hardware environment. So normally you have a PC and then you install an operating system on that. With virtualization, there's a layer between the hardware and your operating system. So the nice thing is on a single server, you can run multiple operating systems. So for example, you can run both Linux and Windows on the same hardware. So that's in essence what virtualization is. When you install, when you have this virtualization layer, you typically also specify what type of CPU, memory, and disk storage you want. And so it could be that the underlying hardware has 8 cores, 8 CPUs, and a 2 terabyte disk. But in your virtualization layer, you can only ask for 1 CPU and maybe 500 gigabytes of disk and 4 gigabytes of memory. Another advantage of virtualization is that you have complete control. So if you install the OS, so you're the administrator and you can install whatever you want. So here's another example. Again, the difference. So we have the hardware and operating system, and then running the applications on top of that. But we can split it with different users, each having their own operating system. And so here you have 16 cores, 28 gigabytes of memory, and then one user uses Linux with 6 virtual cores. It's virtual because the actual system has 16 cores, so actually you use 6 out of those 16 cores, and then another instance is running Windows. What's the different use cases? Okay. We'll talk about Linux during the next presentation. So there are some advantages, on Linux, and we'll see that later on. Okay. So for virtualization, I also want to mention that you can do it at home. So probably most of you are using Windows, but you could try to if you want to run Linux, one easy thing to do is to download Virtualbox. The link is here. It's a free program. And then you create a new virtual machine. So that means if you install Virtualbox and you run it, you say, I want to create a new virtual machine with 1 CPU, 4 GB of RAM, and 10 GB of disk size or something. And then you can install Linux from any image. So installation usually takes about, I don't know, 10 minutes, 20 minutes. Or it can be a pre-installed image and then it immediately boots. That's also possible. And then you can try Linux on your own computer. So just wanted to point out that's something you can try at home. Then that's virtualization. Then there's a new thing. Besides virtualization, there's also something called containers. So container is a different type of virtualization. It's also called lightweight virtualization. So with a virtual machine, you actually virtualize the hardware. So you can install multiple operating systems. But with containers, actually, you virtualize the operating system. So we see that in the image here. On the left, you have your virtualization or hypervisor layers and then different operating systems. And each has its own applications installed on it. But often you don't need another operating system. You want the same operating system, such as Windows Server or Linux, but you want different applications. And so instead of virtualizing the operating system, we use the same operating system, but then we have different containers. And a container is actually just a set of applications installed. And so that can be useful. For example, you can have one application running a database and everything required to run the database, another application running a web server. So it's another way to separate different applications within their own, let's say, space within their own environment. It solves also dependency problems. So maybe one application requires a lot of installations and another application also, but it can be difficult to manage that. If you're running different apps and they each require different things, it's more clean that you have them in their own container. So a popular example is Docker, and it's often combined with Kubernetes to install a server or maintain a cluster of different servers with the same installation. Is it done for more efficient, faster running of different applications? Yeah, it's mostly indeed efficient, and it's more efficient and faster because this container is lightweight. So it's more quickly, you can more quickly start and stop different containers. So that's an advantage. Okay, then a quick overview of some essential AWS services. So we're going to talk about EC2 or Elastic Clouds, Elastic Block Storage, S3, and RDS. So these are, AWS has a lot of different services, but these are the most essential ones, and we'll go over them. What is EC2? It's the Elastic Compute Cloud. So here's a figure of a data center, and you can see different racks here. In each level in this rack, you have different servers, and they're all connected here with network cables and power cables. And basically what you do is you want to rent one of these servers, or create a virtual instance on one of these servers. So maybe have 2 GPUs and 60 GB of memory, and then probably that's using like 1/3 of the capacity of a single server. And so that's loading a virtual machine in one of these data centers provided by AWS, Google, or Microsoft. Once you have created your own virtual images, you can connect to it over the internet remotely. Here's an example of the Amazon console. So you're going to practice with that in the lab session. You see on the left you have a menu, yeah? And you have, for example, instances, and with instances you can run a new server. So here's a screenshot of that, of me running a T2 point micro instance. I'll show you later what that means. But once I have clicked and launched a new instance, it's available for me remotely. So that's one essential part of the AWS platform, and this is really for infrastructure as a service. So this is really the lowest layer of abstraction you can have when you interact with a cloud service. Then you have S3, stands for Simple Storage Service. So S3 is a distributed file system. So that means if you store your files, they are stored on different computers physically. But for you just access your files as if it's one big file system. One advantage of a distributed file system is that you can store terabytes or petabytes of data, so more than would fit on a classical hard drive. So that's one advantage. Another advantage is that your data is very safe since it's stored redundantly. So I'll go into that. For Amazon, they claim a durability of 99.99999%. So the chance that you will lose your data, even if there's some earthquake or something bad happening with the data centers, the data is replicated across different physical locations, and I don't think your data can be any more safe. Can you store data? Wait, one question of Manuel. Can you store databases and access them with Python or Anaconda? Okay, Manuel, can you store databases and access them with Python? So yeah, you can store your databases in the cloud, and then you can connect with them with your Amazon credentials and connect with Python or Anaconda is a system. It's the standard Windows installation which bundles Python and a bunch of libraries. So there's no real difference there. But just with Python, you have a library called Boto, and Boto is the main library you can use to access resources from AWS. So yeah. Okay, so from a user perspective, S3 offers you unlimited storage capacity, and AWS will scale it automatically. So even if you add another terabyte of data, AWS will manage it, will store it on different servers, and you don't have to worry about it. So that's a kind of higher level service. You can imagine if you want to have your own service that offers this kind of scalability, that's a lot of work. You have to maybe copy your files or split your files and copy them over different computers, send them over the network. So there's a lot of things going on behind the scenes when you use simple storage. But as an end user, you don't have to worry about installing software or making sure your data is secure or ensuring physical safety. That's all done by AWS within their S3 service. So the main use for S3 is just storing unstructured data. So there are other services for databases, but for storing media files or for storing any type of file, it can also be JSON or XML, you can use S3. So it's easy to do. I share the link here on YouTube, which shows you around the Amazon S3 console. We don't have too much time to do that during the lecture, but it's very easy. And in essence, you create a bucket, and within that bucket, you have all your directories and files, and and it's like similar to Google Drive or Dropbox. You can just create directories and upload files locally on that using that web interface. One difference between Dropbox and Google Drive is that you control the access for each bucket. So that's a little bit more technical to do, but you can control the access, and you can specify which user can only read files or read and change or write files or remove files. And you're in control of that. And you have to be careful because with all these internet resources, you have to assume that there are a lot of hackers and even automated computer programs, bots. So whenever you launch an instance online and you make it publicly available, you can expect that hackers will try to log into your system within like an hour or something. So that's really something you can tell about if you ever worked with servers online. So you really have to be careful with access and security. Okay, so S3, actually, the underlying implementation is used. Is similar to Hadoop file system. So Hadoop file system is used for processing, storing big data actually. It will also be the main topic in week 8 when we talk about MapReduce and distributed processing. But in essence, you have a large number of files, and each big file, so more than 128 megabytes, is split. So it splits in these blocks. And each block is replicated, and by default on 3 different data nodes. So here in the picture also we have a master node, and the master node is the server, and it manages all the different files, and it has the metadata of the files, like the file size and the name of the file, but also the location of, for bigger files at least, where these different blocks, you split large files into blocks, where these blocks are stored. So that's the master node. And then you have your data nodes, and by default, you store each block on 3 different servers. So why would you do that? Well, if one server becomes unavailable, because it crashes, or because it has issues with power or issues with the network, then that data is no longer available. But if you replicate it on 2 other servers, then the only time your data is not available is when all 3 servers are crash. So the chance that that happens is very small, especially if you use data nodes which are located on different racks or something, or have a different power supply. So that's how it works. So each data node sends a heartbeat every 3 seconds. So a heartbeat is just a message saying to the master node, hey, I'm still alive, I'm running, everything is okay. So if the server doesn't hear from, if the master node doesn't hear from any data nodes, doesn't get a message from a data node, it knows, oh, that data node has crashed, is no longer available, and then the master node will ensure that other requests for the same file that use the blocks that are replicated on another data node, and it will also make new copies so that you have always 3 copies on a data node that's actually working. So that's all. That system is also why S3 has this high durability number and is always available. Then another type of storage is EBS. It stands for Elastic Block Storage. And Elastic Block Storage is actually like a normal disk when you use a PC. So if you launch an instance using Elastic Cloud Service, so a running instance of Windows or Linux, by default, you only have enough disk size to store maybe 8 gigabytes, but you can add any Elastic block storage disk and attach them to an instance. So that's just a regular hard drive. One difference is that typically the disk storage is only available over the network, and you have a lot of choices. You can go for a classic hard drive, which is cheapest, but it's a little bit slower than a solid state disk, or you can have a general purpose solid state disk, and then that should be fast enough to store all your data, and also faster for loading programs into memory and that kind of thing. There's also a third choice. I didn't put it on the slides, but you also have IOPS reserved solid state disks. So these are much more faster, and you also have a guarantee that the disk has a certain latency. So that's a third option, actually. Okay, so we had S3, we had Elastic Block Storage, and then finally databases. So there are 3 types of databases in Amazon. You have RDS, which is your relational database for storing data in a relational data format that can be accessed using SQL. So we will practice that in week 6, I think, and create a new relational database in Amazon and then do some queries on that. Then the second type of database is a document database. So that's for storing non-relational data in JSON. So it's compatible with databases like MongoDB. Yeah, you don't know MongoDB, but it's the most used database for storing JSON documents. And actually, it's really simple. You only have, it has a lot of options, but in essence, it's really simple. You can just store any JSON document with a certain ID and retrieve that document back using an ID. So what's relational data? I forgot. Okay, I'm not going to repeat the entire explanation on relational databases, but a relational database in essence is just a collection of tables. So each table has consists of rows, and in each row you have the same set of columns. For example, you can have a table with users, and then you store the first name and last name. Does AWE also any graph database? Asks Carlos. Actually, I'm not sure about that. But if it doesn't offer a graph database, you can always create an instance, any server using Ec2, and then install a graph database yourself. So for graph databases, you have a popular one, GraphQL, I think it's called. Wait, I have it installed on my machine, graph instance. Sorry, Neo4j, and then you can download and install Neo4j on any, for instance, Linux instance, and you can also do that. And then you also have Redshift, which is more a data warehouse. So in a data warehouse, you also store tables, but typically each table has a lot of columns, like 100 or 50 columns. It's not unusual, and that's more useful for running analytical queries for business intelligence type of operations. So, like the question also from Carlos, does AWS offer any graph database? So you can always install any database technology using an EC2 instance, and then install that yourself. However, if you use S3, RDS, DocumentDB, Redshift, AWS does a little bit more, so it does also the management for you. That means it takes care of backups, it takes care of replicating data, on different servers. For instance, if you have if your data doesn't fit on any single system, you will have to distribute it or partition your data. It also replicates data to ensure high durability. Also software upgrades such as security updates from your operating system or updates to your database software. These are all handled by AWS, and also the scaling. So for scaling, there are basically two options. You can either scale up or down. So with scaling up, that means you just increase the capacity of your instance. For example, if you have 8 gigabits of RAM and you see that your application uses all of that available RAM, you can scale to another machine which has 16 gigabytes of RAM. Same with CPUs or disk space. You can just take a heavier instance and scale up, and then scale down at one time. Or you can also do horizontal scaling, which is called scaling out. And there, instead of having a single server with more RAM and more CPU, you use multiple servers. And then you have a load balancer. And the second, horizontal scaling allows more flexibility because you can add servers dynamically. So, for instance, if at the night there are not a lot of clients, you maybe only need one web server to service some requests. But at peak moments, you can add new web servers. And in Amazon, that only requires a minute or two, and then they all have the same configuration, because also there's a limit at the amount of memory is available in the web server. I'm not sure what the limit is in Amazon. It's quite high, but it won't be terabytes of memory. It will be maybe, I don't know, 200 gigabytes of memory. So if you need more and you reach that limit, you have to go to horizontal scaling anyway. So normally you set that up yourself. But in the case of S3 and RDS and these other services, Amazon manages that for you. Okay, so here's another example. Suppose we have our own websites. That means we have created that we need a network with a public IP address. Then you have maybe a load balancer and 2 web servers. These web servers, they respond and they return web pages to your different customers, and each web server maybe needs some computation that's done on an application server, and application servers are then connected to the database and all these other things. So in Amazon, you can just create that. So if you want to register a domain, you use an application within the Amazon console, and it's called Route 53, and there you can register your domain. You have load balancers available, so it's always called Elastic because it scales for you, and that's why it's called Elastic Load Balancer. Then you can create 2 web servers and 2 application servers using EC2. You can store your relational data in using RDS. You can store what was it again, log files or images that you want. You can store that in S3 buckets, and then you can do some machine learning. Like here it says a Spark cluster for patch analysis. So that will be discussed in week 8 what Spark is, but you can use also, there are also Amazon services that help with that. So basically Amazon has everything, and if it doesn't have a specific database you need, you can install your own database by creating a new instance and installing it there. So the last part of our presentation is to launch your own server in EC2. So that's in the lab session. You have some more time to practice that with Tom. to get a feeling of how the web interface works and everything. So basically, if you launch your own instance, you have 4 price models. You have on demand, and then you pay a fixed price per hour. So some instance, the price is really low, and like if you launch a micro instance, it only costs like a couple of cents per hour. But even if you have a very powerful computer with, I don't know, 16 cores and 100 megabyte of RAM or something like that, it typically costs about €1 per hour. So on demand is very flexible, of course, for a heavy server. €1 per hour. If you have a server running day and night the whole year, the prices get high really quickly. So a second type of pricing model is spot instance, and there you have a kind of market. So you can rent a server and you place a bit. You have like an ongoing price, and actually Amazon uses that because a lot of the time there's servers and they're not used, and with these spot instances you can have the lowest price. A disadvantage of spot instances is that you have no guarantee that the server will keep on running after a couple of hours. So they can decide, if there's no reserve capacity, for instance, they can decide to kill all spot instances, and then your server is no longer available. Then you also have reserved instances, and there you have a lower price than the on-demand price per hour, but you have to reserve, so you have to pay 1 year upfront. And then finally, you can also have dedicated hardware. So in all 3 previous price models, well, I assume you use a virtual machine, but you can also have your own hardware, maybe for if you have really strict security requirements or something like that. You can have your own dedicated hardware, but that's at the highest price, obviously. So what are the steps? The first step, what you do when you launch an instance is you have to choose your image. So you're launching an image, so that means it's a virtual server, and the hardware is already provided by you, but you have to select which operating system you want. So you can have Linux, Windows. We'll talk about the difference between the two in the next presentation on Linux. Those are the basic things. You can also have like a pre-built image. So for example, if you want to do deep learning, you can have an image which has already all the deep learning libraries such as TensorFlow installed. What's also often installed is LAMP. LAMP stands for Linux, Apache Web Server, MySQL, and PHP. And it's a popular combination if you want to run your own websites. It's with PHP, it's a programming language for making websites. It's very easy to create your own, I don't know, a website for managing soccer teams or something. If you're into soccer, you can do that with LAMP pre-installed. Then you have to choose your type of instance. So first you choose which operating system you want, and then you choose a type of instance, and then you have basically a table in Amazon, and it shows you the number of CPUs, the number of gigabytes of RAM, the storage that's available. And actually, for adding more storage, that's another screen. Also, and then you have some specialized option. So typically, it goes from the least expensive to more expensive. And if you go to 8 cores and 32 gigabytes, you will pay maybe €1 per hour. If you just use the T2 Micro, which I suggest you use for the lab session, then it's free actually, but you only have 1 CPU and only 1 GB of memory. So that's not a lot, but it's typically free. So these are the options. So you select your number of gigabytes you want, how many CPUs you want. You have special instances with more GPUs. So for example, for 3D rendering or deep learning applications where you use TensorFlow, you use a GPU instance. Also, there's some special instances which are storage optimized. For instance, if you run a database and the database has the data of millions of customers and you want really fast reads and writes from that database, you can have a more expensive server specialized for high throughput. And also the same for network. So also if you have heavy input-output loads, you can use optimized instances for that. Then you configure your instance. So most of the configuration is about security. So you specify the virtual private cloud network, and you add a security group, which is a kind of firewall. You add a public SSH key, and you attach a role to it. So these are the things we're going to talk about in the next slides, because these are important. So remember, when using cloud services, if you are not careful, your server becomes available over all the entire internet. And if it's on the internet, it means people are going to try and hack it. People or automated scripts are going to try and attack your server. So you have to be careful about security. And another thing you can do is add additional EBS storage. So EBS storage, that's like attaching a disk with additional storage to your instance. So security. So the first key concept is a virtual private cloud. So you have the internet, and then you will have a public IP address. So there will be part of the network in Amazon will, the routers there will assign you with a public IP address, and you can access that from your home. But it's important that you have this local network, and it's actually a virtual local network. And by default, that's configured for you. And the main advantage is if you have like a server containing very confidential data and it's not accessible to the internet, you can have it in this virtual private cloud. So it's only the router that's publicly accessible, and you specify for each server if it's publicly accessible or not. So we do that with security groups, which is the next slides. And so internally in your network, it's a local, it works like a local network. So you can have your domain, and like here it's 172.31, your subnetwork, better, sorry, not domain, your subnetwork. And then you can have a number, the last IP digits are the least significant ones. So you can have a server 10, 11, and 12 within your private network, and they're only accessible through the router. So that's how a private, virtual private network works. Then another thing you have in Amazon is the identity access management. So often you work in an organization and you have different roles. Like normally your, let's say, end users, like people who work with the software, they don't need access. But then maybe you have a database administrator and other people who really need access to the physical servers, and they each have roles. So you have different users in Amazon, and you share the same sets of servers, but you have different users and different roles. So you maybe have the administrator role, who can really change the configuration in each server, and then you have another role where you only have access, but you cannot actually change one of these systems. And that's something you should do when you create a new server. You should always have different users and groups of users and policies, who can access what and who can change what. And that's all also configurable in the interface of Amazon. And then the next thing for security is a security group or firewall. So by default, you only allow SSH access. So we'll talk about that secure shell. And with secure shell, actually, it's a very with secure shell, you have remote access to your server, and you can run commands command line. So you can even install new software. You can delete all files using SSH, using secure shell. So actually, it's very dangerous to have it publicly available over the internet. But still, it's a default because, well, when you first start an instance, you want to install software. So that's why it's default. But here you have this screenshot, and you can select which types of traffic you allow. So you choose the transport protocol, which is always TCP in practice, and then you choose the port. So if you have a web server, usually you would say, I have port 443. So that means you can only use that port. And if on that port you run your HTTP server, your web server, that means you have a web server that's publicly accessible over the internet. Is it still useful to encrypt confidential data when using those services? Yeah, so security, it's very dangerous because the command line that sends, no, so SSH, the first question from Oberon de Deurwaarder, is it dangerous because command lines are not encrypted? So SSH, we will see in the next slide, it's encrypted. So use a private public key, and it's actually very secure because you use a private public key. But it's dangerous because if anyone gets your, if a hacker has your private key, then they can just delete all your servers and delete all your data. While if you just allow HTTP, then people can also do, hackers can also do strange things like send 1 million requests at the same time to your website and crash your website maybe, but at least they cannot delete any data or something. So it really depends on your firewall. Basically, these rules say what can other people do, which services can they access. So is it still useful to encrypt confidential data when using those services? So with confidential data, there are different layers. So the security groups define the network level security. So they define which people in which parts of the world can access which services over the internet. And while encryption of data, it's more important. It's another layer of security. So I would definitely recommend, I think it's even mandatory these days with European regulation, to encrypt all confidential data as another layer of security. Okay, so the secure shell, what does it do? Well, with SSH, you specify your username and then your server. So your server, if I'm going back to this screen, actually I mean the router. And the router is a public IP address, and then it will forward your access to one of your instances in your virtual private clouds. And only if that's allowed by the firewall. But if it's allowed, you can connect to as a certain username, so that has to be pre-configured on the server, and connect using a domain name or an IP address with the server, and then you're able to run all these commands in a terminal. And in the next presentation on Linux, we'll see some commands. For example, ls-lah returns you all the files in the current directory, the file names. So you can use this secure shell to set up and configure your instance. And how does it work? So that's the question on encryption. So with SSH, by default, you use a public-private key pair. Yeah? And so you use that because it's much more secure than a password. A password typically has a limit of 10 characters or something. So it's not that secure. Well, here in the image and slide, you see an example of a private key. So this is a XML large string. It has certain mathematical properties, such as being a large prime number that makes it impossible to hack. Use with brute force, while with passwords, it's known that, for example, a password that's only 8 characters long can be hacked in an hour or something. So with passwords, you always have to be careful. But in theory, this private key is unhackable. If they don't have your private key, they cannot decrypt any message you send encrypted using that private key. And so that's the default you do with SSH. So the private key is locally installed on your laptop, for instance. And the public key is what is stored on the server. And so using the public key on the server, the server knows that you are a registered user. So that's how it works. So it's secure, but still SSH is dangerous because you can run commands on a remote computer. So the last thing you want is to share your private key with a hacker in some way. And then you can connect to a server. So you type SSH. So you can type that in Windows 10. I think it's installed by default. Otherwise, you have to install some software like PuTTY. I think Tom will explain that during the lab session. But you SSH, you give your private key. It's stored in a file. You pass that as an argument to the SSH commands. Then you can connect to a remote server with a certain IP address. It's here. And by default, it's port 22. And then Ubuntu is the user. So it's your username on the remote server. Here it's Ubuntu. Often with Amazon, the default is EC2 user. So that's how it works. And this communication is very secure. So it's end-to-end security with the public-private key pair. Normally, that's unhackable for any man-in-the-middle kind of attacks. So if you launch a new instance, you can download. The public key is automatically installed on the server. The server also has an SSH processes started and listens for. It's available for getting messages for remote commands. You also have a public available IP address and a kind of auto-generated domain name like this one, EC2 18203 and so on in DNS. And then you can, with this line, you can connect. So username, typically EC2 users, and so on. Okay, that concludes the last slides on the cloud. Any more questions? No questions? Okay, we'll see if I have time after the presentation on Linux to show some examples. Otherwise, you will see some examples hands-on during the lab session. I propose we take a 5-minute break and then continue with the presentation on Linux.